let's look at layouts. A layout is a view type that is able to contain and hold other views. And the goal or purpose of a layout is to allow you to provide structure to the user interface by having a container that can hold on to and allow you to arrange as detailed as you would like all the views that the user actually sees, whereas the layout itself is invisible. So layouts are used to provide UIs to activities, as well as application widgets, which are these little mini apps that run within your home screen, as well as things like notifications. So you can create very basic notifications in Android, or you can create custom notifications where you provide your own layout file. Now, creating a layout can essentially be done in two ways. You can create a layout by describing the UI elements in an XML layout file. So we call this design time creation. And the second is to do it using code. Now, this is the imperative mechanism. It oftentimes has a few downsides, not the least of which is it does in fact require the integration or the combination of your code and your layout considerations, which is not always the best approach for designing anything because it breaks what's called separation of concerns, which is if something is concerned with A and something else is concerned with B, if you can keep those things separate, it usually helps. It helps you build, it helps you maintain, and it helps you reduce errors. Additionally, in this method, you really can't see what you are getting without running the application. And that is, of course, if you're doing it in code. Whereas by using the design mode, building the XML file, what you see in your layout is usually what you then end up with in the rest of your application. So you are able to visualize without much effort and then run your application without too many surprises. Now, this is a very, very basic example of a layout file where we see we're using what's called a linear layout that contains two views, a text view and a button. We see that the linear layout has its own attribute set. For example, its width and its height are set to match parent. That essentially means, hey, fill up the space. And then we have the text view and the button that both have IDs, but are set to have their height and width wrapped, which is only take up the minimum amount of space that you need to display whatever information you need to display. Again, this is the simplest version probably that you can come up with for a layout file. And one thing to note is that every layout file must have a single root element. So at its core, this linear layout is the root element. It's the start of the tree. Everything else must be contained within it. If we were to have, say, a separate element outside of this linear layout definition, then this file would not be able to compile. So we must have a single root element in which everything is contained. Once you've defined a layout, you can use it for, say, an activity by calling setContentView in that activity's onCreate and passing a reference to the file with the prefix r.layout. This r.layout will be discussed in a subsequent lecture, but for now, just type it verbatim. The good thing is when you create an activity, by default, this layout file is already created for you and this line setContentView is already added. So you shouldn't need to add it or change it unless you, whether inadvertently or something else, created an activity without a layout file. Some common layouts exist in Android. Linear layout is a layout that organizes children in a single horizontal or vertical row. A constraint layout allows you to specify the arrangement of children by constraining them or anchoring them against siblings, i.e. other views inside the constraint layout, or against the constraint layout itself. A web view per Android's own documentation, is treated as a layout. Essentially, a web view is a view type that is able to display HTML content or hypertext markup language. Basically, it's able to show you web pages. Again, whereas it very much feels and acts like a view, Android's documentation lists it as a layout, perhaps because HTML content tends to include the types of elements that you would refer to as views, such as buttons and edit texts and drop-down lists. So the web view itself is then perhaps referenced as a layout for that reason. Now, each layout type, and there are many beyond the three we just showed you, has internally defined a set of rules that dictate how child views placed inside that layout are going to be arranged, or what are the rules that define how they're going to be arranged. So what that essentially means is that when a view is placed in a specific layout type, a certain set of attributes are exposed for that view that can be used or will be used to specify how that view will be placed. Technically, those properties, those layout specific properties, are defined inside of an inner class to the layouts class called layout params. And the arguments or the attributes that are defined inside that specific layout params file will vary depending on the layout type. The only exception perhaps being width and height are present in all of them, because knowing how the view should look, the size is a necessary piece for any view. Now, because a layout can contain views and a layout is itself a view, that essentially means that you are able to create these tree-like structures where a layout can contain a layout, which can then contain other views. As such, it's important to have an appreciation for how the layout params argument, or the layout param rules, how they will apply to a given set of views. So for example, here we see at a root element, we have a linear layout. Of course, a linear layout defines a set of layout parameters that will apply to all its child views. So in this scenario, we'll see that this view, maybe this view is a button, maybe this view is an image. We see that this view has the layout params class of the linear layout defining how this view can look and how it can be arranged. Similarly here. This constraint layout is a child of the linear layout. As such, it is also governed by the linear layout's layout params. So how this constraint layout will look or be arranged or sized inside the linear layout will be defined by the rules of the linear layout. Conversely, the constraint layout has its own set of views, its own set of children, and their arrangement inside the constraint layout will be defined by the layout params class defined in the constraint layout class. So if you want to think of this as parent, children, and grandparent, you can think of it that as the parent is able to tell its own children what to do, the grandparent is able to tell its children what to do, including the parent of the grandchildren. But the grandparent cannot tell the grandchildren what to do. Now, whether that's true or not in real life is not the point here. But in this context, that's what we're saying. Each layout gets to tell its children how they're laid out. But a parent can itself be a child, in which case its arrangement is governed by its parent. So let's take a look at some of the considerations and differences that we can actually observe as we modify our layout types. So as mentioned, Android actually does contain quite a few layouts, and if you were to say do a search for layouts, you might see quite a few of them. let's take a look at just two, the constraint layout and the linear layout. So the constraint layout is the default layout that is created for us. In fact, it's what you see here being used with this layout file. On the left, I have something called a component tree, which is just giving me a view where indented items or indentation indicates that these are children of the unindented component. And if one of these were to say that itself be a parent, then I would have all the children to that parent being with additional indentation. So this currently has a constraint layout as the root element. And the rules of a constraint layout say that every child will be constrained, or its arrangement will be determined by how it is constrained against child views, other child views, or the parent itself. Now, this has certain considerations. First, one rule of a constraint layout is that each view must have at least two constraints. One on the x-axis and one on the y-axis. Now, let's take a look at what happens if I say break that rule. So I am going to take this button and I'm going to break its constraints. So I'm using this little tool to remove all the constraints that were applied. So right now it is free of constraints. This seek bar is still constrained to it to some degree. I'm just going to remove that one constraint so that the seek bar sort of is only constrained to the parent. So this button is free. Here's what happens if I now run this application with the button not being constrained. As you can see, it flows quickly to the top left of my screen. I can still interact with it. It's still a button. It just doesn't sit where I would like it to sit. It doesn't sit where I had it arranged in my design. So when you place a button or any view inside of a layout, a constraint layout, as you place it there, it sits there. So you are allowed to manipulate it and design it. But when your application is running, it respects the constraints. So you always have to constrain it. Now, as mentioned, you need to have at least two constraints. One on the x-axis, one on the y-axis. If I were to have only one on the x-axis, that would be problematic. In fact, if I look in the component tree, I can see that I'm getting reports of errors specific to the arrangement, to the constraints. But I could simply get away with doing just these two. The warning disappears, the error disappears, and now I can basically say that, okay, I want this to be a certain number of pixels away from the left, and I want it to be a certain number of pixels from the bottom of the edit text. And this may give me what I want, it may not give me what I want. Just try to appreciate that when this application runs, it will respect the constraints you've applied, even if those constraints don't really work. Meaning, if this view, for example, gets pushed off the screen because it's being run on a device with a much smaller screen and it doesn't have this many pixels, so it pushes it off the screen, well then it just means the user won't be able to see your button. So you always have to be careful about how you place constraints. So everything must be constrained at least twice, and then you basically apply certain rules. So for example, by dragging to the left and to the right and anchoring both the left and the right, and without having any bias or anything else, this is basically saying my button is going to be centered on the horizontal. If I would like to center it in the vertical, I can do that by simply repeating. It's dragging this all the way to the top and all the way to the bottom. Now centers it in this right in the middle of my layout, regardless of the size of the layout or anything else. Oftentimes, that may be the case for one view. Maybe you want to use that view as your anchor, so you kind of place it in a fixed position and then you sort of arrange everything else around it. In this case, that's sort of what I did with my hello world. That was serving as kind of my anchor, and everything else was sort of arranged around that. So this was anchored only to the parent. Then the edit text was anchored in relation to the edit text. The button was initially anchored in relation to the edit text. And then the seek bar, similarly, could have been arranged only against the button. Now, one thing to note here, if I were to say, take my seek bar and arrange it to be constrained to the end of the button, notice that the size shrinks accordingly. And that is because my seek bar is set to have its width be match constraint. This is what match constraint means. It doesn't mean take up all the space. It means take up all available space. And in this scenario, we've said constrain yourself to the left and the right of the button. So the only available space is the boundaries of the button. So again, this may be what you want, may not be what you want, but you do have a lot of flexibility and a lot of freedom to manipulate views, and this will impact how they look and how they're arranged. For example, you might recall that because I anchored everything against my hello world, when I was doing my manipulation of the views, changing the size of hello world shifted everything around. That is because that's what my rules said. And this can be dangerous because here we have a scenario where I could make it so large that my seek bar falls off the screen and I have no way of getting it back. So at this point, my interface is non-functional. So you do have to be careful about how you constrain things. So in this scenario, for example, the solution might have been, well, don't constrain my seek bar to the button. Instead, constrain it maybe to the bottom of the screen instead of the button. And at least in this scenario, I won't run into problems where my seek bar disappears. Yes, something may push past it, but at least it will remain on the screen because nothing that's moving is pushing against it. Because it will respect the constraints that you placed on it. Now, let's compare and contrast this constraint layout with another layout type, the linear layout. So again, what we have here are a set of rules. And if I go to code, you can see some of these rules. Layout constraint end to end off. Layout constraint horizontal bias. Layout constraint start to start off. These are all attributes that make sense in the context of a constraint layout because these are all defined inside of the layout params class found inside the constraint layout. These would not make sense inside of another layout type, such as a linear layout. So we can actually test that to see what we get by simply changing the root component. So to change the root component, all we need to do is take this containing layout, which right now is the constraint layout, and change it. And if what I'm going to do is select split so we can see the layout and the code at the same time, I'm going to get rid of the blueprint and only look at the design so it's nice and neat. And then I'm going to change this to linear layout. And as I change it to linear layout, you'll notice something. A bunch of my views have disappeared. And they've disappeared because the linear layout is laying out the children, laying out its child views, this text view, this button, this seek bar, etc., horizontally. It does that by default. So this hello world is taking up a certain amount of horizontal space. The next child is also being laid out horizontally, so it takes up a certain amount of space. And everything else is now off the screen. We've run out of space to lay them out. I could kind of fix this by making the orientation of my linear layout vertical, and that at least brings a couple more views back to the screen because now instead of laying them out horizontally, left to right, it's laying them out top to bottom. So hello world, then click me, then enter name, but I'm still missing some stuff. So the point here is that the way that a linear layout lays out its children is very different from the way that a constraint layout lays out its children. And in fact, now that I'm using a linear layout, these arguments don't even make sense anymore. The linear layout just ignores them. It doesn't register these as values that have any meaning. Rather, a linear layout has its own set of attributes that it introduces. And we can see those attributes if we go to design view. We are going to see that the attributes window is going to look a little different. Certainly, the common attributes and all attributes, they'll still have a bunch of attributes that we can set because they're specific to the view. But all the attributes that relate to the layout that contains the view are different. For example, we had a widget here that allowed me to drag or to see and remove anchors or remove constraints. That's no longer here because views inside of a linear layout don't have constraints. So we'd have to now look at the necessary properties to arrange our views inside of a linear layout and then manipulate them appropriately. Same if we had something like a frame layout. A frame layout lays out its children along the z-axis. So elements are on top of each other. So now we see all of my views basically just piling on top because that's what a frame layout does. So again, I'd have to manipulate these views based on the rules of a frame layout to get the result I want, or simply go back to a constraint layout, which gives me the original design that I had because the properties or the attributes that were set make sense to a constraint layout, so I immediately get my original layout back. So that's how we can use layouts to arrive at certain outcomes in an application. This is how we can use the GUI to drag views, manipulate, and change attributes. And this is how we can build engaging and useful user interfaces for users to interact with for our Android applications.